Let's take another step converting our interpreter. Let's change the treatments of expressions from data type oriented to object oriented. The operation that we care about on expressions is interp, which takes an expression, again that's implicit with objects, takes an environment, and it gives you back a value. And now we need to make constructor functions for each of the existing variants that we had for expression. That is, we need a num_e constructor, which takes a number and gives you back an expression. And since it's an expression, then it's going to be a function that takes an environment and gives you a value back. And this function, the value that it gives back, is supposed to be the interp result of the expression. How do we interp a num_e expression? We immediately produce a num_v expression. So that's the whole implementation of the num_e constructor. We've taken care of that one. We can look at IDE. IDE takes a symbol to make an expression. And since it's an expression result, then it's a function that takes an environment and gives you back a value. How do we interp an IDE? Well, we need to take this S and look it up in the environment. We could call lookup like that, but of course we have replaced lookup with the notion of objects for environments. So the way we call the lookup method on an environment object is just to call it like that. That's the ID case. The +e constructor. +e takes a left expression and a right expression and gives you a new expression. So like all expressions, it's a function that takes an environment and returns a value. The way we used to interp +e is that we had a left and right expression and we would interp each of them. But remember that what we're doing here is replacing interp with methods on these objects L and R, where you call the method just by applying the expression. So that means calling L on M gives us a value back for the left expression's value, R on M gives us a value for the right expression, and since we've got two values, then we can just add them up like that, and we're done. Multi is going to be similar, and so on for LAMI and API. We just keep implementing what used to be the interp function here in this body. And when you push it all the way through, then you get somewhere like this. You can see I've implemented all the expression variants here. And my interp function now doesn't have the cases anymore. It's just a helper wrapper that calls the interp method of this expression A by applying A to its environment. All of our tests pass as they did before. And now the advantage of an object-oriented style is, let's suppose that in addition to these variants that we have here, I want to have a negation form, which has a sub-expression, which should produce a number that I'm going to negate. So a negation is going to construct a new kind of expression given a sub-expression. That means it's implemented, again, as a function that takes an environment and gives us a value back. We interp A by applying it as an object to the environment, and then I can use num times on num_v minus 1 to actually negate it. And notice now that I can interp a +e of a neg_e of a num_e5 and a num_e7 in the empty environment. And I get back 2, just like you would expect. But the key thing here is that I didn't have to change any of the old code. I did this all in the interactions window, in fact. It used to be we could only add neg_e by changing interp, but now I'm able to add neg_e on the outside without making any changes to any of the other code. So I've added a new variant without changing the code.